All right, so I will try to do first a short introduction about what this is, and try to set up a bit the stage about what I'm trying to achieve with this workshop. So okay, who am I? My name is Lucian Ghinda. I'm a Ruby developer. I curate a newsletter that is called Short Ruby. I'm all over the place in social media, but could not find the same handle on all of them. So there are different ones there. And why I'm doing this workshop is because I am a Ruby developer, but I also did a lot of testing workshops over the years. There is a repo here, which I will put this again. You might download, but my intention is not to write some live code, but more try together to do some test design. So we'll mostly talk about how to test something and do some drawings and extract some ideas. And I will not invite you to actually describe context test, because that is easy to use the DSL of the either Minitest or RSpec or some other testing framework. You can do that, of course, but I will push to this repo further on today all the tests that we are going to design here. But I would like more to have a conversation with you. So mostly I will present something here, just a bit of, I don't want to call it a theory, but a bit of explaining why I'm saying testing can be systematic, repeatable, and then ask you to interact a bit and ask you what would you test, and then together we will give it a form, if you are okay with this. Okay? So please, just try to answer to me if you want. No bad answer here. We're trying to go together toward the direction. So my main purpose here is to answer a couple of questions and to show you how I approach these answers. One is, how do you know how many tests are enough? And another question is, how do you know if your tests are covering enough business logic or whatever criteria you put there? And another question is how confident you will be, or you are, that your tests are covering the important parts of your code. So mostly I'm talking about, this is a screenshot from Mastodon source code, but this screenshot is not about this is bad or good, but I'm just imagine that you are either wrote this test, right, and you prepare to do a commit, and you might ask yourself, did I wrote enough tests? Is there something else to write here? Or a colleague is asking you to review their pull request or merge request, and you might ask yourself, are these good enough tests? And I know that the first answer that we give is something like, did it cover the lines? Right? When we talk about coverage, did it cover the lines? And while that might be a minimum required metric, that does not guarantee that the paths in the code or the conditions or some states are covered. Do you agree with this? That covering lines of code will not specifically test everything, although everything cannot be possible, right? So my objective here is to do this in a systematic way. That means to model the universe, to show you 4 techniques, how we can model the universe of all possible test cases, not write them, model them. Okay? And then define some coverage that we want to achieve. That can be, I want to cover all ifs, true and false, or all conditions inside an if, true and false, and these kind of things. And then identify the minimum number of test cases to achieve 100% coverage in some cases, and do that in a systematic way. And I will talk about 4 techniques. There are many more, but in 2 hours, I think I choose those, and I hope I manage to go through all of them one by one. And let me tell you a bit about the structure. Is like, I will tell you a bit of background. I know I put theory there, but I will not go fully into theory, but almost all of them can have a mathematical expression of why they work that way, a combination of mathematical expression and probabilities. Right? And calculate the total space, and then we'll identify the minimum test cases in case of low risk, and then we will grow from there, and then define the concept that I like to call good enough testing. So what is the purpose? The purpose, to understand the purpose, first I think it's important for me to define here what do I mean by tests, or what tests, right? So in my experience, when I'm writing tests, I'm trying to achieve the following goals: to verify requirements, right? To make sure that what I wrote is according with some requirements, to document some behavior, and this is mostly sometimes in documenting some edge cases or some decisions that were taken, and validate user value. Validate that the problem that I was trying to solve is solved by this. Now, in this workshop, we'll mostly focus on the first two, because validating user value means that we should have a requirement that makes sense in a business case and we understand the end user, okay? So the first, I did some animation there. So what do I mean by good enough testing? That means that considering the level of risk, we define some kind of coverage criteria that will drive the test design so that we can achieve 100% coverage with the minimum number of test cases. Why I put this definition here that I just invented is just to signify something that here we don't guarantee 100% exhaustive testing. Right? So all the things that I will present, they mean to cover some kind of level of risk. They don't guarantee that you will test everything. Right? So it is in that context. So basically, another diagram. Basically, that means that, let me do some maybe writing. So that means that we go from low. So what does it mean, a low risk? A low risk means that if something bad happens, nobody will be upset and we don't lose too much money or whatever makes sense in your own business, right? And in this case, what kind of test do I want to write? I want to write the minimum number of tests, and I want to rely more on the programming language or the framework. So for example, if you are, in this case, let's say probably everybody is using Rails, right? In this case, you might not even write a test that a validator of a presence or a length or numeric, right? You rely that the framework will do it. So minimum. And then we increase a bit the risk, and my assertion is that most of us probably write the most tests into this medium area, right? Where what we want to choose a coverage criteria that fits what is tested and focus on the minimum effort with maximum coverage and do it systematically. And I will come back to this word systematic in a bit. And then there is high risk. High risk can be either someone suffers something, or we lose money, or we charge the customer multiple times, but something that will upset a lot someone, right? And in that case, we want to go more toward formal testing methods. That means we want to make sure that we covered some possibilities. And sometimes we talk about covering all cases, and we maybe talk about proofs that it works, and we might going into I don't know, avionics or high risk areas, right? To talk about how we apply static analysis for proof that it works. Sorry. Right, so mostly what we will do will be in this medium, as I said. So let's start with a simple example. I just wrote here I'm not a product manager, but I wrote here some requirements. But the basic of these requirements is that we have some kind of credit card or I don't know, assurance or something, and we want to check the age. And it says here, if age is over 18, you should apply, right? So the Ruby code might look in different ways. This is one way that someone might write it. This is another way that it might be. This is another way how it might be. This is another way how it might be. This is another way how it might be. And if you were to the presentation about the VM, the YARV, you might know that you can write it in so many ways because Ruby is super flexible, right? You can also try to coerce, or to address some error cases, and I'm not even talking here about RBS or sorbet about what happens with the parameter there, right? But what we want with our test is, of course, to document how it works, but we also want the following, I assert. If someone makes that change, I want some tests to fail, no matter how it was written, right? If someone does this change, I want the test to fail. So in this workshop, we will not focus on the shape of the implementation, although we will use Ruby examples, but we will focus on the functionality. So you give it some inputs and you have some behaviors and or some outcomes. That might be true, false, or I don't know, an integer, but also exceptions are outcomes. Right? Or exits or some other stuff, or returns or some other stuff like this, right? So we will cover what people are defining specification-based testing, and that means testing based on the analysis of the specification of the component of the system. And we will mostly ask what unit test we write there. So if you think about any of this piece of code, right? Let me ask you let's take with one very simple one like this, right? What test would you write? Just tell me the inputs or the idea. Just shout out.
Testing for not numbers.
Not numbers, okay, yeah.
For negative numbers.
All numbers? Yeah? 17 and 18? Empty string? Yeah. You can even give it the object as an input, right? Like, what else? Sorry? Type, yes. What else?
Maybe numbers over 1,000 and 200s.
Right, yes, sure. So all of these are valid tests, right? So let me go here and I will not write all these answers, but ask you the following. If we brainstorm half an hour or 1 hour, how many tests like this could we generate? We could generate, right? We can push ourselves to generate. Specifically in the case of Ruby, we can push ourselves and we can generate a lot, right? So then when do we stop? We might, so is it enough to say, I will test something less than 18 and bigger than 18, 2 tests? So if a colleague of yours will have given you this code, let's say, right? And only test 10 and, I don't know, 50. Will you have accepted this pull request? No, okay. What would you have asked more? Maybe test some negative or string and so on. But, sorry?
Other types maybe to match that course?
Yes, okay, in this case, yes. So maybe we want to match some conditions in that course, which is written like this, but can be in other places. So maybe we add at least 2 or 3 more. Yeah, exactly. So we might arrive together to a number of them, and we generated now, and I think it will cover everything. My plan is to show you how to make this so that it does not depend on me or any of you, and everybody that sees this code, if it applies the same procedure, it should arrive to the same test cases. So coming back here, I just put here the code so that I don't open an editor, but you might write 2 of them, right? Which we agreed that maybe these 2 are not enough, right? We might make it a bit more, and we agree that maybe this is also not enough. It's a bit better because it puts the 8 in there, but we feel like maybe this is not enough, right? So how can we make this methodical? We go to what I said, systematic testing, and that means a structured, methodical approach to achieve this. And it's like, if me and you will write some tests, they should look the same, okay? So that means the same number of, what I mean by same, the same number of test cases and same assertions, but for example, if we talk about something less than 18, someone might put 10, someone might put 9, that's the same test in a way, okay? So someone that puts 17 and 18, that's not the same test, and we will discuss about this. So basically what we want to do, and I will go to the first technique, is that if we have some kind of inputs and a function that transforms those inputs into an output, right? The first technique is called equivalence partitioning, and that means if I can split the input domain into partitions that are having the same behavior, I will go back to this definition, I just put it here. So basically what I mean is that if I can split it like this, it has the same behavior. All of these ones are doing the same here. Sorry. Then we can say the following. We can say that we covered with tests, if we choose from each of those partitions one representative, and we check it. Okay, that's not enough, but we will talk about this. So equivalence, but when you can apply it, just shortly, when you can split the input in set, I will not go into set theory, but set meaning a group of things that we put together that are having the same behavior, and coverage criteria means to go to all these sets and test them. And the total number of tests is equal to the number of sets of these groups that you do. but I don't use groups because that's another mathematical concept and we'll use it in some other place. Right? Okay, so let's see more like going to this one. I simplified it a bit, and let's try to do this. I will show one example here and then I will explain it. So how is this done? I split the input domain in two if I don't focus on typing and coercing, right? So I focus on the behavior of the requirement here. The requirement does not say it should not be a string because the one who wrote it, it's about business, right? So I split it in two and I have two sets. The one all natural numbers lower than 18 and the all natural numbers bigger than 18. And there is a concept of valid and invalid, and valid means that the requirement defines something there. It says what it should do, right? And invalid, it means it's unsuccessful. And I have two tests here. So I write these two tests. Test case one, test case two. What if I add more code here that you already saw, right? Then I feel that I need to do more. Of course, it remains on the natural numbers the same split, but now the number of partitions is growing, right? I have the initial ones, and I keep I just put here two of them, just two of them, but as you generated, we can put more. Now it comes the idea how many of this invalid you can do, right? And you have to have a stop about this. Sorry, let me just go further. So if I only remain of these cases, then I write 4 test cases that you saw there, right? Less than 18, bigger than 18, and then age is a negative number and age is a non-integer. What I did here, I just specified the code without going into generating creative ideas of how to break it. Okay? So that was simple. So let's take an example that is a bit more complicated. It's generated for me. So let's say we have some criteria and someone defined some kind of eligibility for discount, right? So it says age criteria, and it's about, let's say, booking places to an event, and it has a duration of these events, so some criteria. And our code might look like this. We don't focus on the specific, but it's like, I want to check this criteria in some ways. And then each of the criteria is like verifying age requirement. If it's verified, like greater than 365, return true, else add some error and return false, right? So, and it does something there. And the same about booking count, it does a count and checks that, adds an error, and some duration and checks that and adds an error. Now, this is not like super real, but I wanted to put something that is more close, not that simple that it's just a number and you go back and forth, right? It's a bit more different than numbers. It has numbers, but there is a logic there. So if you think about this type of code that has this criteria, right? What test would you write about it? So let's try. Let me try now to. I think I screenshotted this somewhere. Yeah, something like this. So if you will write some tests, what would you consider? What test would you do? Again, let's brainstorm. Nothing bad.
We can consider a truth table. We can discard all discard the lines which lead to the same result, and we can write maybe 5 or 6 variants which are left here, maybe less.
So I agree. If it's a truth table and let's say we have 3 conditions, we have 8 test cases minimum, right? Like only for the main, let's say there are 3 conditions, we don't know what's inside. Let's assume the other methods are private, so we don't want to test them directly, okay? So, but we will have at least 8, right? So we might choose 5, 6 from them, that can be.
And also we need to check like
not an integer. Which one should be not an integer here?
I mean, you have my apologies, you don't have an input on each.
No. I have an active record model, let's say.
Okay, then we can discuss.
But it isn't the direction you feel, probably very good, that we also want to go maybe a bit in the kind of invalid things, like how can I force this in some ways? And maybe it's not an integer, but can I make the count not persisted? Right? Or like, is not totally corrupted data, but I try to go with it in invalid states. That can be, let's say, not persisted. Something else? Yeah, maybe 27, right? So the same question that we ask, these all are good, and if you have time, you should write all of this and brainstorm more, right? Like if you have. Sometimes we don't have time, and sometimes we have to take a decision to say which one it should be, and where do we stop? And if I pick 10 out of these 27, which one should be? And more so, how can I explain this to a colleague why I choose those? Right? Or if a colleague sends me a PR, how can I assess that the decision to choose those is good? So, in this case, I took this example because we can apply multiple techniques to it. So we are first to the technique that is called equivalence partitioning. This technique is mostly concerned with the following idea. Does this work in general? Like for normal cases, does it work? Normal cases meaning, for example, if I choose a booking count that is not minus, or if it can be like Jean Boussier presented in the first day something that this can go to minus if you were at the talk about Rails bugs, right? So, but a normal one, right? A normal representative of the number of bookings, let's say, does it work or not? So this type of things. And again, I'm coming back to this one because in a way you can just read this and then we can stop the workshop in some ways because this is the core of it, right? The number of test cases grows as we want to cover more or more risk and be more attentive. So a model of this can be the following, right? I say, hey, how can I split the account created that? I can say the following. In this part, I have a partition that is less than 365. Trust me that I put the numbers, the correct one from the code here. But you can also check it in the repo. So I say there are two behaviors here. It's less or bigger, right? And about booking count is less or bigger. And about booking total duration is less or bigger. Okay? And as you mentioned, it's kind of, if I do this, it kind of is similar with the truth table because we are actually checking truth values and the total number of cases is 8. And this 8, me and my colleague should arrive to the same number of test cases, the 8 test cases. That's the combination of each one with each one. Okay, it's like this 8 means I want to take this one with this one and this one. I want to take this one with this one and this one, right? And then I want to take this one with this one and this one and so on and so forth. Okay, and it might be that some of them will repeat, and you might reduce a bit of this. Now the thing is that this is good when we have three conditions. Maybe you should write that because it's fast to write it. But because we are talking about powers of 2, if you add the fourth one, then suddenly it increases a lot. And if you have fifth one, it increases a lot. And this is not an if with multiple conditions, it's just logic there that gives you true and false. Right? So it increases a lot. So then we might ask ourselves, what does it mean good enough when this increases, right? And my proposal for this definition of good enough is the following. I try to find this is confirmation bias, right? I try to find a study that is saying in a more scientific way the following, truth that we might feel that the majority of the bugs are generated by a single condition. Yeah, exactly. But I found one that counted some things, right? So when we don't have time or there is a pressure or the risk is not high enough. So for example, if I will talk with people that are working in airplanes, I would like them to do the all test cases, right? But if this is for the subscribers of my short Ruby newsletter, let's say to pitch it in, maybe I don't need to do all the 16 or 8 test cases. Maybe I can just check a little bit more in one condition, right? So, and then if you imagine, this is like, just showing a bit, this is 2-dimensional, but we had 3-dimensional, but I'm not good at drawing 3-dimensional things. So you have X and Y axis. If you want to test all of them, that means all the green dots here. This is the test. But we can ask ourselves the following question. How can I reduce this? And I will show you 2 ways to reduce it that is repeatable to many inputs. I'm just showing you 2 here, but the algorithm is important. So you say, I want to focus on one single influence. Of course, I need to execute all of them, right? An account is created. But when I focus on X, right? I focus on X. Then what I want to do, it's this is X. I want X to be invalid here and valid and invalid here, right? So then how do I choose the Y? I choose a valid one because I want Y to be true and to test what happens with the influence of X here. Does it make sense? Right? And when I go to, Y, I pick this other one. So this is medium, right? Medium risk, in a way. What if there is too much pressure? Like I really need to release it very quickly. What is the minimum that I can do and still repeatable? Right? The minimum will be to make sure that I wrote enough tests that each X and Y independently are invalid and valid. You know what I'm saying? So what is the minimum that each one of them go through the state of invalid and valid, right? So in this case are 3 test cases. Oh, for this one, right. So let's try to apply this to our own example. So imagine in the beginning we had 8 examples, all of them, right? What we can do, we can test combination of valid and each one invalid. And it might be like this, right? I want to do this test, all valid. And then a second test is account created that is invalid and the other 2 are valid. So I always keep the other 2 valid, right? This is a second test. Third test is like this. Booking count is invalid and the other 2 valid. And the 4th test is like this. Okay, does it make sense? Right. Can we reduce them more? Yes, we can reduce them more, but with a lower risk, we can say, I do this test, all of them invalid, and this test with all of them valid. Again, this is about the level of risk and being repeatable, like if someone asked me what I did. So, just to pause a bit here before we go to the next technique. This is not a technique that is, oh my God, amazing, we discovered new math here, right? And probably, if you now go into your commit history and open some tests that you wrote, you might have fitted in this one. My purpose was to show to you an approach that is systematical. You can explain how you chose them. I don't start directly. I'm looking at my code. I don't know, something like this. And then what do we do most of the time? We go into a file named test, let's say, right? And we start writing the first things that comes to our mind. I'm not sure if you did that, but I am doing that sometimes, right? Most of the times, before discovering this. So before I write the test, these are tests already written, I want to do that thing, and usually I write the assertion. This is super Maven. I will try to do a demo with it afterwards. Not a good thing. I try to write what I want to test. So it's like age criteria is invalid, booking count is invalid, and booking duration is valid. I don't fill in the body of it because this is just a suggestion. I don't fill in the body because then I get focused to details and I lose the context. And I write the second one. Sorry. This is invalid. Let's make this valid and this invalid, and so on, right? I write them and then I fill them in. I will not fill them here, but This is what I said. We don't have to write this code because it's like, it's a simple code to write. We'll spend time writing age equal to and so on. That was the age validator actually, but it does not matter. So this is about equivalence partitioning. Any questions about this one specifically before we move to the next one, which adds a bit of complication, but not that much? Yes?
Do you try to extract the boundary value analysis into a data structure that you iterate through to generate the test instead of flagging all every single?
As a personal preference, I never do that loop in tests, but I saw people doing it and it works. I'm not saying no. I'm trying the test to be as explicit and procedural as I can, and make sure that, there is no error due to the fact that I wrote a simple small algorithm in them, right? I'm not saying it's bad. I saw code bases working also like this, but my personal preference is just to write them like that. And with AI, they will try to fill you in also the details here. But my idea about using AI in testing, I never say to AI, write tests for this. But it works well if you know the technique and you say, write equivalence partitioning and write the following test cases. This invalid, this valid, this invalid. I control what I ask. This is how I will apply it. Other questions about the equivalence? In case of equivalence partitioning, so in case of equivalence partitioning, so for example, 0 has sense in ordered groups, you know? Here we have, of course, numbers, and numbers are sets, but also ordered groups. But you might have, for example, a group that is the people in this room. Okay, and the people in the other room. And where is the boundary between these two groups, sets? This is why they are sets. There is no boundary. But if we go into groups, then I agree with you that, and we'll talk about this boundary value analysis, it's concerned about where the behavior changes. And we might transform some set into groups if we put an order relation. So we might say all the people in the conference alphabetically ordered. Right, so then I have a previous element, not element, person, the current one and the next one, right? We can maybe talk, it's just a general example about this. In case of 0, for example, 0 exists 0 as we're talking about count and so on, right? But equivalence is concerned about if I am, let's say, I will put it in numbers, but if I split this in two, equivalence partitioning is concerned with the following question. What is the most representative? What is the free tool? Okay. I have two partitions here, and it's concerned saying, what is the most representative average item of the group on the left? So that is, to say this, the element here is not an average element of this group. It's a special one there to the border. And we have a technique about that. Does it make sense? Super. Other questions about the equivalence before we go on? Yeah.
Boundaries for, let's say, strings, or string-like data.
Strings, okay.
An example would be looking at code, redacting out emails out of strings.
Could be, yeah. Yeah. We go into boundary now, like just to explain. Yeah. So you should give yourself a very nice green check that you feel that just applying equivalence is not enough, right? You feel like, hey, come on, I want to do something at 0 or 18 or in our case with eligible, where it's 365 and what happens with 0 and 1 and these kind of things. And that's a very good feeling that you have. Because we need to go into that. And boundary value analysis, it applies when we can divide the input domain into ordered partitions or ordered groups. They are together, but we can put them in an order. And I will not go fully into the theory of this, But this is also concerned if you think about mathematics with the identity element and the incremental step and the generator of a group. Like you can add something to an element and obtain the other one. This is the case where this can apply. But for simplicity, we say it applies when I can divide in groups and I can say the element before, the current one, and the element afterwards. Okay? So you apply it like that. And what is the coverage criteria? You want to cover each boundary value, the boundary lower than boundary and higher than boundary. Actually, this boundary, you can read more about it, and there are many techniques. I'm just summarizing here one of them that is very commonly used, but it's concerned with many other stuff. And the total number of cases is the total number of these boundaries that you tested. So it sounds very formal, but it's very simple. If you imagine the test case about 18, right? In requirement, I have only 18. If I want to make it simple, what test do I have to write? A test for 18, a test for 17, and a test for 19. Now, coming back to that, is not in my requirement, but I can, if I have time, I can say, hey, you know what? There is also 0, which is not in requirement, but because these are natural numbers, in general, people have an age that is a natural numbers, there is 0 that can be the boundary to integers. So in that case, the tests that I do are -1, 0, and 1 also. So every time I put a boundary, I need to test coming toward boundary, the boundary, and going out of boundary. Does it make sense so far? All right, so let's say if we do the simplest one, I will write tests like this. I put them here so that we don't spend time writing. You will have wrote this, but I hope you agree with me that writing this one is not that, and you might use RSpec, so you format them differently, but I will write this, right? Now, the same question, what happens when we have multiple input, right? So these are 2 inputs here, X and Y. Then if you do combination of them, then if you do combination of them, then you have to cover all these dots that I put there, because this is how it gets, right? And still, this is also, you can count them and you can have the total number of cases. Now, what if you can remove something? What you can remove? We apply the same logic. What if I want to focus only on the X1, right? So then I want to keep the Y valid. So then I choose this one that are colorful, right? And when I focus on the Y, I want to keep the X valid. Okay? So I reduce them. And maybe you may ask, what if I have less time and there is not too much risk? Can I reduce them more? And of course, yes, we can. So in this case, if I focus on the X, so let's go here and do an observation here. You see, if I focus on the X1, right? If you look at some tests where this one and this one, they test the same boundaries when we think about X, right? So they are kind of a duplicate. They are not duplicate when we think about risk. Like, can be an error because of combination of Y and X, but if I can reduce something, I can focus on that. The same is true for Y. Is like, I notice that this one and this one, when I think about this axis, they're kind of similar, right? So what do you think I remove here? I grade them out in a nice thing. These ones and these ones. So in the end, I remain with this and with this. Less than the one beginning, but again, I remind you, it's about the risk that I'm willing to take. But still, what I wanted to show is that I don't just remove things, delete some tests because there are too many. I need to have a way, a repeatable way, explicable way, how I remove them. Okay? So let's try this out a bit more concrete, right? So I wrote here for you, for each one of the inputs, let's say, or influences on that method, the boundaries, because it was simple for me to write it. So what test would you do? If you were to cover to cover all possibilities, what test would you do? Just tell me, each test needs to have 3 inputs, right? Three switches. Which one? Like you will do a test like this?
Yeah, well, the 3 values. Like I would go for those 3. So, like, yeah, the line.
Yes.
And that test like is the record.
Yeah, and if you go for this one, how many tests would it be? Or it's coming back again. I'm using this just to show to you that testing is not. It should not be mystical. It's mathematical. This like when you have 3 groups, if you want. It's the Cartesian product of the element in those groups, and the Cartesian product is 3 in the first group, and 3 in the second group, and 3 in the third group. Right? So 27. Yeah, it is. What does it mean just to put it here, right? What does it mean, this? It means that I want to do tests like I want to take this one and test it with all the combinations of the others. This is the Cartesian product, right? All points. So, and of course, if I add also 0 and 1, this will increase a lot. How much? Just tell me a number if I take all of them. Please? 125, right? Why 125? It's 5 times. Yeah. A lot. But what I found it nice, we can calculate this, right? This is the maximum. So if a colleague sends a PR 130, that's too much. Right? It's too much. Come on. Right? Now, you feel it that come on, I mean, 125 just to cover these things, it's too much in a PR, right? Even if you write it yourself and you're passionate about testing, let's assume, right? So we want to reduce it. But this is the maximum. And it's nice to have the maximum. But because, why? A colleague is telling you, write more tests. And you say, how many more? Because 125 are the maximum ones, right? That's the maximum. So this is what we discussed. It's here. I put it here just to have it. What we can do is we can minimize it saying, you know what? I want to do the minimum. That means I want to make sure that I go to each boundary, but I don't count the combinations. So there are 5 tests in this case, right? This one. You can take some other groups, but the purpose here is the following. I want 0 to be tested at least once, and I don't mind which combination, but at least once. Does it make sense? These 5, I took them like this, but you can make some other crazy stuff, but make sure you don't repeat them, you know? And how do you feel about this number? Would you make a PR with this or accept it? No. Everybody's a no? Okay. It's mostly toward no, but an optimistic colleague might offer you a chance to yes, but you feel like this is maybe too little. But again, if you are pressured by time, at least you have to do minimum this. So what I know by this, so when I calculate minimum and maximum, what I know is the following. If someone sends a PR with 4 tests, that's not for sure good. I don't need to read them. Right? I'm not saying don't read them, it's your colleague, but or if I'm writing test and I wrote only 4, I don't send it, right? Don't send it, it's not. But we are talking here about theory. In reality, sometimes you have to finish the work before 2 o'clock or whatever, so, but at least minimum. So what might be, I don't know, a better thing, right? What might be a better thing? We apply the same concept as before, and we say, we want to focus on each one of them, boundary, and keep the others valid, working cases. Not boundary, working cases, right? So this is an example here what I did. When I focus on this one, I keep the others valid. And if I will focus on this one, I will test with this one. And of course, this one, right? And let's see how many tests would you think are here. I don't ask you to calculate on that, but just as a feeling. Oh, okay, yeah. I don't know by hand. I really need to calculate it, but I was just trying, right? So 13 cases, because some of them are repeating. But if you said 15, yeah, I mean, you got it, and when you write it, just don't write multiple times or install Robocop to not let you write multiple times the same test. But yeah, so if you see these tests, how do you feel now about either submitting it or accepting it? I think it covers, right? It's like goodish. You can maybe reduce it a bit more with some talking about, should I test the zero really, because it's a count of records in database, and of course can be zero, but I can put an early return. I mean, maybe you can work a bit with it, but if I'm saying I don't want to take into consideration the shape of the code, like if it uses guard clauses and so on, I want mostly to focus on, I make sure that the requirement is implemented correctly, then maybe I go into this one.
In this case, when you're talking about like mounting records and stuff like that, or looking at creating that, I would not test the zeros anymore.
This is what I'm saying. So I put it here maximum, right? Because, okay, this is by coincidence, not by coincidence, but I use this example so that I go into multiple examples with it to see that you can apply multiple techniques on the same one. But I can agree that you can reduce it, but when you reduce it, try to, of course, invent a reason for it, but try to not invent, but pick a reason that you can explain, and you can connect it with the risk, right? So like, what is the risk to those to be zero and let be eligible? Well, we have to look at the code, and if we use guard clauses, maybe it can. I also read the code, not only the test, right? But yeah, good observation. I was putting the same example as you're saying, right? So what I can do to make a minimorum, but probably not accept it. You already felt it when we have 5, right? It's like if I have 3, that's very low risk. You have to be in a very high pressure and very low risk to test only these ones. So if someone sends a PR, they should say there, I really need to release this now, in a way, let's say. Anyhow, so you're mentioning very well a truth table earlier, right? So there is a technique specifically about that. But before we go there, any questions about either boundary or equivalence or both of them? Yeah. For the boundary? I understand. So the idea with boundary is that you focus first. How I will design this. Let me go somewhere where I have some space here that I draw on it. So when I make the boundaries, I first focus when putting the boundaries when I know the behavior is changing, and in our case it might be 0 in the sense that minus here might throw an exception, which can be an outcome of this method in some ways, maybe, right? And 18, and then I fill in the other ones, but I did not put minus because it's hard to say that I can obtain a -1 count. You can, but that's a very special case. You can obtain some other stuff, of course, there. Does it make sense what I'm saying? $364. Yeah. The method says you have to go through all of them, but you can reduce it like this if you have a reason for it. So here is an example where, just giving you an example that I have, where maybe testing 0 says something. So for example, imagine you are using null objects. So you say when an account has no bookings, instead of saying no bookings, I want to display something specifically for the null case. right? So you can implement null object pattern. So that makes sense to put 0 here to test how does it behave with the null object. But I agree, it is a case, this is what I'm saying, you can reduce it, and I agree, he also said the same, like maybe I don't test the 0, but like the model says you have to go into known directions of boundaries, let's say. There was another question. To the other one, right? This one. Why 19? Imagine someone will have written instead of age greater or equal to 18, initially age less than 19, but maybe mistakenly also put an equal there. I mean, this is a very simple example. Maybe you cannot believe, like, let's say something like this. You have 18 boundary, 18 plus, let's say, 18 boundary, right? How can you express that in an if? You can say age like this, but you can also say because it's integer like this, and they are the same, right? And this is simple again, but what an error can be here, you know? I mean, the idea behind boundary is two. One, to make sure that you tested, it just says lower and higher, but if you do the test, you also know where the problem is. You know, like, because what happened here, the person who did the implementation moved the boundary, right? Made the boundary 19 instead of 18. Why? Let's say 18 is valid age, right? So I want 18 to pass. What happens here? This is true, right? With 18. And what happens here? This is true. So if I run this, like, sorry, when you say, yeah, it's just like maybe this is not the best example because it's very simple. This example, right? It's a very simple example. But imagine that you don't have this. You don't have this thing simple in your code to take a decision to reduce it. So you might want to stay with the pattern that says less boundary and more. If you feel there, please. Yeah, I agree with you. If you move the boundary, menu will fail. You can write only 2 if you want, and I want to tell you that if you look for boundary testing techniques, you will have the following 4 types of boundary: weak, robust boundary testing, strong, robust boundary testing, and some other cases which are concerned with these smaller details. But I choose the main technique that is just concerned with boundary lowest and highest, like to make it simple. But actually, both boundary and equivalence have more forms of how you apply them. So you feel something good there, that there is a discussion about it. But I simplify it so that I can present it. Yes. Yeah, I agree. I totally agree. I think my case also previously did not work completely, the examples that I gave. But yeah. There was another question about these ones? Yes. There is animation, so wait a second. This one? Can you say louder? This one, 1 and 9? Could be, but as I gave an example, the difference in our case, looking at the code, does not make a difference, right? Because it's a count. But again, you can transform. I even at some point show an example that you can make a has association and make it return a null object when it's 0, and a real association when it's 1, right? So then in that case there is a difference between 0 and 1, in the sense that in one case you return an object, and in another that's not array, and in another case you'll have an array and then count on it. You know, like in our case, I just show the maximum, and you can remove them. But these things here are, and this is I think a thing that maybe I should specify a bit is that even though we are making this test based on code, you should not make them strictly related to how the code is today, because you redo something based on the current code and you move on to another part of the feature, and a colleague comes and changes that, and it might not change the test. But also, I agree, if there is no time and you have to remove something, one can make sense to reduce it, and even as other people were saying, maybe together with 0 if you don't have time. That can be. Sure, but yeah.
Same approach, like you're taking the criteria and using the criteria to make a test rather than using the...
You raise also a good point for me to say. So I wanted to say this in the beginning, that I don't say that you go test-driven or not. So I was only focused on this, and because some people are doing that, some people are just writing the code first, and for me, I don't want to have an opinion about this in this workshop, and not focus on that. But yeah, depending on how you apply the technique can be. But if you are lacking of time, all the reasons that you are saying here can be applied. Just apply them and maybe explain the reason, or make it obvious why. Could be, but sometimes we have some code that is already written, so yeah. The same. Other questions about this, or I move to? Is it okay? Is it clear so far? Super, thank you. So, decision table. Of course, decision table. It's a, let's say, an evolution of the truth table, in the sense that in this case you can do a decision table with more than 2 values for a rule. But because we are in IT, we know that even if you have 4 values for a rule, you can always make it true and false, because everything can be made true and false, right? So if we say this is an account, let's say, and it has a status. And let's say I compute the status, and I say the return of the status is based on some conditions: archived, closed, expiring soon, update required, and so on, right? In this case, my status has more than 2 outputs. So I want to do a decision table to expand all of this still in true and false, right? So what I'm saying, this is not enough to just make this false and say I tested status, or make this true and say I tested it, right? So coming back to this before we go there, because this is mostly about how we build that, it's when to apply when you have 1 or more actions or conditions, if you want, that are like the action is determined by a series of conditions. And the coverage criteria is to execute all of them, and that is the maximum number of test cases, but you can condense some of them. So let's try to build this together in some way. Templates. Whatever. I just prepare a template here so that I don't put the checkboxes and so on. So basically, 2 things here. When you are doing a decision table, the first thing in the process of creating it is to ask what is the knob that I can turn on and off to influence the output. And the tendency might be that I put this here, archived. But that is not the knob that I turn on and off. I need to look at the code. I hope I have it here. Statuses. Account. I need to look at the code and see what is this doing. This is archived present. So the input that I put here is not archived because I cannot influence that. I have to put here archived, right? And this can be present or not, right? So I don't need to put more. I can put it true and false, and I can make it present if you want to make it explicit, but I give to this one true and false and activate that. And the same with closed. Closed at present, let's say, right? Is this enough at closed? Probably, right? This is the only one, present. Expiring soon. There was something like this. So here, this one gets a bit more complicated. I cannot just put there expiring soon because I will fake myself in the number of tests, in the influence of them, right? So I have here eternal. So what is this eternal? Expires at nil. So it seems like this can be a case, and all right? And then expired, and what is expired? It's expires as, let's put it today, not to write just Ruby code there. And then it depends on the soon to expire days, right? It's an interval that it's 30 days. So I have expires at, so. Sorry, can you say it out?
Different things that you're testing, like things that depends on other things. Like it looks like you are testing, for example, behavior of some attribute that has to be in other, and you can like just like mock the answer, for example, of expired or closed.
I agree. So what happens if I put here expiring soon and not all the others? Sorry. And I don't go into the details. What will I miss? Expired nil. Right? That's a special thing. It's an eternal. It has a label. You know?
But on the other hand, like these methods, like expiring to update required, they can be tested separately for their behavior.
For sure, but what I want here to test is the influence of some inputs which are hidden here. Because I could have written all of them explicitly instead of extracting methods. So a good point here. So, you know, when we are doing abstractions or we want to give better names to things, right? So what I did here is I made a nice name for this case. I name it eternal. Let's say, right? Because we are concerned, and that's good, with concepts from the business domain or from the domain, right? And we want to refer, not to say to the product manager, or I don't know, support or ops, expired, we say that eternal account, I don't know, let's say, right? We are extracting this, but this confuses the actual logic that exists there. We are hiding the conditions with naming. So naming is good, and extracting smaller methods is good, but what they do, they hide the rules and conditions. They are hiding them in testing. So you will see that here, I will probably not have time to make this completely, but here I could have just put these 4 things and try to test them, but I will have missed stuff from it. And I agree with you if you say, but this is hard, and this is hard. Yes, because when we put abstractions there, we make it nice in OOP or domain name, but we hide that. I'm not saying you should write everything in one single method, of course. I'm just saying when you try to make the tests, pay attention to truly go where are the knobs that will influence the output of the function. So if I will draw a function out of this mathematical one and I will express it as domain, I will need to say what is X and what is Y that influences. Please.
Can I ask you what
Yeah, of course. Yeah, it's a good thing. I don't have the requirements here, so if I will have requirements, so let's say someone was giving me status means this, right? Status means this. I will go there, but I just made this example because this is more real than to say, where are the requirements for this? Well, somehow this evolved from not having concrete requirements. But if there were be requirements, those are the rules that I put first here.
This is what happens when you encounter a legacy code base.
Yeah.
That's essentially, right? So that's
Yeah.
the reality for a lot of people.
So it can be that if I have requirements, for what I write, it's the rules from the requirements. I agree with you, and that's the best. The best in the sense that this is how you make sure that it provides value to end user, that it respects that. Also there, what I do sometimes when requirements are written, I create this table and give it back to the product manager because we have the tendency, and it's a human tendency, to express only positive logic. And not always the requirements include all the combinations that the truth table can have. And also, what is hidden here in this case? The order.
Yeah, I was going to say that.
You know?
If it will be archived, then the other cases are automatically
Exactly.
archived.
So when the requirement came, obviously the requirement person, I don't want to name specifically, right? Might not have, because it seems obvious, if it's archived, cannot be expiring soon. But that can be as a state in the database, right? Can have the archive set in the period of expiring soon. It does not make sense, and maybe they did not write it explicitly there. But it exists as a possibility in the code. Does it make sense?
No, I always try to find business rules first and then try to make it so from here, I would do this a different way. I would try to figure out what's actually, can you make an archive unarchived? And like maybe wouldn't, rely on just one table having these attributes, but maybe a list of events that happen, things like that.
I am not sure I follow.
So, like a state machine. Yeah, like a state machine. Similar, or maybe I'd sort this out using event sourcing rather than just having one table representing a state while there are multiple states represented in that table.
Yes.
And we try to build, in here we try to build logic on top of this complex combination of attributes. This is really hard for a PM to understand. If he would bring a new requirement, you would have to explain this whole table to him, and I see where you're going with it.
So two things I want to say here. I agree with all of you that say I will rewrite every code to be better. So if you can rewrite this and you find a new way, do that. I agree with you. That is one case. So, but I choose this type of codes because I wanted to show that sometimes I don't have the option to rewrite this. I also have example with a state machine, so it's not that I did not think about state machines. I know about state machines. But sometimes you don't have it as a state machine, and you have 10,000 customers that are hitting live an API with this status, and you might not, your current feature might not be specifically about refactoring this one. Does it make sense, this first thing? So you inherited this, right? I mean,
Also, when you inherit this, if you want to rewrite it to the state machine, first you have to know how it's supposed to work. So
yeah.
it's like a chicken.
And the second thing, but this is more personally, and it has more to do with how, but it's just a personal thing. It does not have anything to do with the workshop, because this is just an example so that we have a complex set of conditions that are hidden into abstractions for me to create a decision table, right? I choose something. But if you ask a question, but now we go into another maybe talk that I don't give, but just saying, I don't always put things in database. first. I know state machine is nice to put it in a database thing, but sometimes I like a bit to start with computed attributes until I figure it out things, because it's easier to change this than to execute a migration in parallel on a database that has a lot of records to fix a status that is now renamed. But I agree with you, if I can change this to a state machine, maybe that's clear, so sure. Sure. That's the standard one, yeah.
Yeah, like we just had to restructure we had to rewrite our whole permissions matrix with new roles. And we had like having a decision table and an algorithm to do that. And when we were testing it, it was basically like we actually had to do that with every single role and made sure that every test was, and then you're doing things where you're like, if this role is allowed to do this, then you would rename them and stuff. But when you're mocking them, you can't.
Yeah.
You can't just mock the create action because you need to actually test everything through and through. So it was very difficult to make sure we had every test case covered in that situation. I think it would have been a really good example for the decision table.
Yes, I mean, in general, when you have even the one that we had with verify can be put into this, right? So every time you have a set of rules, that they can be true, false, or they can be A, B, C, D, each one of them. It does not have to be binary, each rule. You can make a decision table. I choose this one just to show to you the idea that you have to dig a bit deeper and not put the first things, nor the first explanation. Even if the requirement was saying if account is eternal, do, I don't know, return whatever, if it is something else, but the ability of us to write a proper requirement that covers all cases, it's not 100% without putting it into the decision table. But yes, I mean, that's a better example. I just choose this one to go through the idea that you have to dig into abstractions. Right? If it is a requirement, if A then B, else if C then D, you just put this in a truth table. If it makes sense, right? And I will do that for authorization or for permissions for sure. But I will do it also for this one, which might be a state machine, but actually can be also created with a decision table. Is it good so far? Or did I convince you with something? Or no? All right, so what I will do, I will just to go a bit through this. So I put all of this from there. I will not write all of them. And then I fill this in. If this is binary, I make some things. It might be that, for example, if this is present, this does not make any sense, right? So I will arrive not to build it here, but trust me, it can be built. I put it here. So I can arrive to something like this. It has more theoretically, but some of them does not make sense. I mark them like that. Also, some of them, like you see rule 5 and rule 6, they can be combined because it seems to me, and let me tell you this is called compression. If you look at these two rules, so if you want, the maximum number of test cases are these ones. Actually, the maximum number are 1, 2, 3, 4, 5, 6, 7. So that's 2. That's the total number of test cases for 7 conditions that are true and false. Okay? Then this mostly we don't write. Then we reduce it because some of them does not make sense, right? If it's archived, cannot be closed, and nor eternal, the other does not make sense. I can reduce them. And I can reduce them more if I don't have time by looking at it and observing when one of the rules, in some cases, does not influence the outcome or output or the action. So for example, in these two cases, we observe that website being present, it's if you dig deeper, website being present, it's under update required. Just to show you this. Where was this one? So we go here, we have update required, and what is this? This is website blank or expired. I know you will say this is not a good code, but my idea is that you should be able to apply testing to any kind of implementation, because life, like this is how it is. If we will have written perfect code, then no need for tests, but we are not writing perfect code, so we need tests, let's say. Anyhow, so there are multiple things. I don't deconstruct them all, but that's the idea. You go and find the knobs. And what we can observe here, we can observe that, for example, in these cases, and what are these cases? This is the case when it is already expired, right? We can observe that this does not influence the outcome, right? No matter if the website is blank or not, the outcome is always update required. Actually, this has to do, if we talk about Ruby, but that's dependent of the programming language, and you should not base your reduction from the beginning on this. It has to do, of course, with the short circuit of these things, how it works. Or if this is if I put this first or last, or if it's true and false, and so on and so forth. Sorry. So this can be also rewritten. Huh? Sorry. Like this. And now you see it better, that it does not count. Again, sometimes we don't choose how the code looks. And nobody can explain, why did you not put expired first? I don't know, when I was writing this, there was no status, and it only started with this one. Imagine, this could have been evolved by only an account. You need to update it to fill in the details. So an account only had one status, active and update required, right? And then you make changes to it. Anyhow, so you reduce it by this, you reduce it to lesser by noticing when one of the rules does not have an influence on the outcome, on the actions. You can make it true and false, and the action will be the same. Does it make sense, this one? And then I just write test for each one of them. And that's all. Any questions about this? Please.
Yes, I have a question. So, thank you.
My question is, often what happens is you add an additional condition, which might lead to an inversion of a rule, and then you add something. So not that and something becomes as a new change requirement. What I often end up doing is remaking the decision table from scratch and then evaluating. Do you have any advice on how to make it an easier process to introduce change like that?
Yeah, okay, got it. Very good question. There is no systematic approach to that, then they just redo it. I mean, because the influence might be different. What you can do maybe is to pay attention to know the truth tables of or, and so on, and think about if I add a new condition, and if I will read it everything in one single line, right? And I add a new condition, how is it added? For example, if the new condition is an or, then I can maybe tweak this easily, right? Because it makes everything true if that is true. So I have one single test case maybe to add. But if that is, again, if it's hidden in some places and I cannot see it very clearly, I have to redo this in some ways. That's the thing. Yeah. Other questions about this one? No? You're good so far? We have just a little bit more. One technique. There are a lot more techniques than these 4 ones. But this is the time. So basically, state transition, as you felt very well, again, congrats, is that, hey, you know what? These statuses, even if they are written like case, they feel like a graph. What is missing a bit is transitioning between them. Again, why? Because it's hidden inside the abstractions how you transition between each one of them. Do you agree with this statement? Meaning, what does it mean transition? How do I go, let's go here. How do I go from, I don't know, active to update required? That's a transition that here is not so clear. You know, because the purpose that maybe someone wrote this code was just to show the current state, but don't think about transitions. Of course, if I'm lucky enough, if I'm lucky enough that someone wrote this code, I have the transitions obviously there. And this is just one of the gems for state machine. There are many more. I don't want to focus on the details of the gem, but someone wrote explicitly those. But before we go into this, to think about testing, that means you have a state transition, so that means when you can apply it, when you can represent the logic or the code or requirements as nodes and transitions between them. Nodes and transitions. Now, actually, this is called a directed graph, not a graph. It has a direction, a way to go through it. So then if you think about this graph, before we go into this theory, because this technique is only knowing about graph, that's the whole technique. How many things you can do with a graph if you think about execution or traveling through it? What you can do with a graph? How can you travel in this? What intentions can you have to travel through this graph? An open question. So you travel, imagine these are cities and those are roads, and you want to go in vacation and you want to make a purpose. I want to, and what can you say about a suite, like many cities connected? What can you want? Sorry? The shortest path, yes. Yeah, the shortest path is a property, yes. But what can you want if you are having a number of cities? Yes? Sorry? All of these are good properties, yes. Yeah? That's also a property, yes, I agree. But I'm searching for something else. Yeah, that's a property of the graph. But it's just not useful for testing in a specific way. But yeah, it is. But here are two very basic things that you can say. I want to travel to all cities. What does it mean in graph? I want to make sure that I got to each node. And it has to do, as you mentioned, with shortest path to do that. So I'm not saying no to what you said. Those are ways to achieve the objective, right? An objective can be, I want to travel to all cities. There are people who like to take pictures of nice scenery, so I can have a second objective. That is, I want to travel to all roads, right? So then I have multiple things in this one, multiple ways to travel it. Let's see, right? And then I can ask questions, and those questions about shortest path and so on are ways to reduce the number of test cases, right? So now this graph has a property. What do you feel about doing the red number of things or the blue number of things? Do you think there is a thing that you can say about these two?
We only can test actually A to B, A to C, C to B, C to F, C to E, C to...
That is a transition, that's a path, right? How do you arrive between C to D? You go to that line, no? Or what do I miss from this?
Why does it make sense to test in the context of state machine?
It has to do with this property. So, a good question. So, let's say I want to go only through the nodes. Right? Is it something that I did not test it here? Yes. So if I say to myself, I only want to go to the nodes, it might be that this is like pay with credit card, and this is like arriving into giving you the card back because it gives you the money, or you don't have money on your account. You know, if this will be an ATM. I will show you an example, but just generally. You know, so it might be that in a state machine, you can arrive to a state in 2 or more different ways. This is why. So, and this is a property of an oriented graph that says the following: if you go to all edges, these lines are called edges, right? you for sure got to all nodes. But the reverse is not true. That's a property. So coming to a concrete example of this, I was just drawing this. So we can have two main categories of tests that we can count. One is cover all nodes. This is the minimum that we can do. And sometimes we can be lucky that this is equal to go through all transitions. But and higher than this as number of tests and risk, it's cover all edges. And there is another one higher, testing impossible transitions. So things that are not defined, but you know what? Someone that goes to ATM can try to do them. You know? And that case, that has almost the number of ways has to do with the number of transitions and nodes. It's calculable, but a bit harder, but it's big. So what I say by this is, in an ideal case, I will also want to try to assert that the red lines are not possible. And you say, how? Well, I try to force the input, right? How can I make it? So let's go to a concrete example. So here is a status of someone that attends a conference, let's say, right? Subscribes to this workshop. And initially it's registered, and then let's see, what are the nodes here? I have to identify them, right? So registered, attending, confirm, and canceled, right? Sorry, and check-in, yes. And what are the transitions? We have them, whatever, attend, confirm, cancel, check-in. Now you have to trust me that if I draw it, it will look like this. Maybe you can draw it better than me, I mean, I'm pretty sure. I use anyhow Excalidraw to write better. But you can trust me that, let's say, it looks like this. And so, what test would you do? And an important information that we have to know to start our testing, or else it goes crazy with the number of tests, you also have to identify the initial state and if there are any final states that you cannot go back from them. And I mark them here, registered, cancelled, and confirm. You can see them on the graph, or you can read those, but the initial state is, this is a simple one when it has one initial state, but you can have two or more. And the feel about it? Goodish? Sorry? You feel that you need more, right? Now, of course, you don't have time at all, just at least these two, right? You in this case, at least need to go to each state. But we feel that it's missing things. Why? Because a participant can be attending and check in, attending and, registered and canceled. Maybe that's a better example. Or, I don't know, can have a fast path from registered, attending, and confirm, and does not do check-in because it come here in the first day at 11, did not go to the registry desk, or things that are possible, right? So then, what is a good number of tests that we can do? It's we try to go to transitions. I did not put their names there, but they have names. These transitions, right? We give them names, but we then need to do one test here, and then a second test here, and then a third one here, and maybe, yeah, 4. Sorry, whatever. 4 and 5. Yes. I draw them next to, just to be sure that right? 5. Okay. Now, if you write this, would you stop after 5? Or if someone sends you a PR about it, would you accept it? Right? In a normal case, yes. What if this is about money and money from your account or credit card or PIN?
Maybe like from the different states to see the different transitions from that point. So I would
But how do you go directly to attending if the state is like this? Like
Oh, in the test, obviously, you can create a record that's already.
you create it like that, yes. I think could be valuable. I will not, but could be valuable.
And like for that matter, I would obviously aim for tests that would ensure that you can't do it invalid.
So just talking real, more real thing. Which one was this? Attendee. Okay, so I put some extra things here, just thinking about a question like this, right? So maybe I want to go directly to confirmed, but maybe I have side effects of going through nodes, right? And in this case, it's simple. The side effects is one-time firing in email. It does not influence the other nodes, but I could have had a side effect that can affect another state. So if you don't have side effects like things firing, you can go directly to maybe set up the test beginning somewhere. But if you have the side effects, you have to follow the path that should be followed. You know, like.
That depends on your test setup, right? If you set up your test to take that into account, that should be fine. But that's really a matter of complexity.
Yes and no, I would say. So the idea is the following. If this has some side effects, like after transition, before, around, different gems have, if I skip them, what do I test? That's the question. Because the user, the actual user, does not have the possibility to skip them, you know. So I tend, if I can, and if there is time, I tend to write tests that follow first the path that the user might take, and usually the user cannot do the stubbing, right? But
Yeah, but like if you use something like factory work, for example, you would probably have cases like a user that has.
I agree. I will write tests like just to. I think I have something. So again, this is Minitest, but it does not matter because it's not a workshop about how to organize your code inside test. I just choose Minitest because it's Ruby inside, so we don't talk about that. But for me, if I do something like this, my tendency is to try to separate the graph from the implementation. So I will try to go to the states to arrive there, or to execute transitions to arrive there, if possible. I might sometimes, I don't think I write it here, sometimes I might check intermediate, but I check intermediate states when I'm trying to do invalid transitions, like this was not possible and I'm still trying to move forward, if it makes sense. When it's possible, I agree that doing it like this has you pay a price for doing like this. What is the main price that you think we pay when we write tests like this one? There are many, but I'm just curious. I know one. One is performance, because you go through them, right? You have to go through them.
It feels like you're skipping ahead in some case. I don't know.
With this one or with what you're proposing?
You're doing the attend and the check-in, right? And basically this test assumes that those two steps will absolutely work.
In this specific case, I assume, so that's a good point. So what we know about the graph is that I do this, right? When I have final states, and then I do this. And how do I check that I did this? How do I check that this happened? I put an assertion here to make sure that I got through this point. It will be a separate, or of course, here you go. If you have the bank, right? You can, but you can also put. I added here just for an example because then it becomes similar with the code, right? You should assert intermediary steps if the library does not allow you. And now we go into the fine territory that is not in this workshop. What you rely to the framework and what you test yourself.
Because in the interest of saving time, you could scrap that test because you're already testing it in the other test.
I don't want to say yes because I don't know what.
That's like, when you're talking about like I don't have time, then that would be.
If you don't have time, the minimum it will be 2 tests in this case, right? Like, yeah, of course. I rely on that, yes. This is what I'm trying not to say here, that something is bad, is because you have to put risk and time into it. So I don't say it's bad, but this is what I ask you, not it's good or bad, but how you feel about accepting it, to not put the word good or bad on it. So what we can do more than going through all paths, we can try, as I told you, try to force transitions that are not allowed. So to say, hey, if we decided that here, either if you cancel, you're not allowed to go to the conference, can you still go into your account and try to uncancel in some ways? Maybe you are a developer going to a developers conference and you open the developers console and you try to force a submit with some values. That I'm not saying, again, this is if you have time and the risk is high, right? This is outside of a normal behavior. So then I will try to test things. And here the combinations can grow very fast, and it's not powers of 2, it's powers of the nodes here and transitions. So how can I limit that? How can I limit this now? Still do the invalid ones? Sorry, first, there are a lot of them, right? This one, this one, this one. I can try different combinations. How can I limit it? And there is a process to limit that, please.
You could probably identify the critical ones.
Yes. So multiple ways. One is what is the critical ones, right? So here is very simple.
Thank you very much. You send an email, you pay, you register a transaction in some banking system, and maybe you ban someone from the conference which they do not want to go. You do not want them on this conference. So in this case, maybe probably the critical route would be registered and cancelled, attending and cancelled. Yeah. And you may not want to check attending and checked in because that doesn't matter too much, especially if you're short of time.
Yeah, I agree. So if you have access to the requirements or how she defined it, right? You want to test some critical things that you don't want to happen. And just to frame it, so you choose based on risk, right? That's a risk to say. If you don't have that, or you feel that's the best, and this is the first thing with the risk to reduce it, right? Then let's say you don't have that because, I don't know, you're a consultant and you jump in a project or something. You ask for that, for the risk. Let's say you don't have it. What you can do, systematically, you can say, I will test only the final nodes. I don't know which one is critical, right? So I cannot reduce it. But I can try just to focus on final nodes. And I can say, hey, what test can I do? This is a test, and this is a test, and this is a test, and this is a test. A minimum when not knowing the risk. But if you know the risk, then go with the risk to reduce. If not, then this is what might happen. So I have them here, these paths, but we discuss it. And then that. So to summarize a bit in one nice table, when to apply and what we got through so far is the following. So equivalence partitioning, when I want to apply it, because in your code base, when you work on a feature, you will actually write tests from multiple perspectives, okay? And I know that you saw here some names, but these were for the workshop, but don't name the file with the technique. Name it with a feature or with the risk, but I put it here because for me to show it to you. I just wanted to say here. So not this, right? So again, coming back here, when do I apply it? Equivalence partitioning, you can apply it everywhere where the input can be split in sets of similar behavior. Boundary, you can apply it when the inputs are continuous, or as I said, you have ordered groups. Decision table everywhere where you have complex conditions or conditions with multiple input combinations. So rule-based behavior. And she gave us a nice example about permissions that I like a lot. state transition when the behavior that you are testing can be represented as a directed graph. And for each one of these, we discussed at least 3 representation of tests. One, we try to calculate the maximum number of test cases that can be, and sometimes we saw that can be very big. And then that is like trying to cover somehow the biggest risk in some way. But again, covering the biggest risk means also a lot of invalid, like exceptions and so on. But the total number, and then we try to reduce it to a kind of medium risk. And then we also gave some very simple example about what could be a very minimum thing if there is not too much risk about this. So, any questions? Here. Yeah, please.
Have you heard of sublayer, like the AI agent framework?
Sublayer, okay.
Yeah.
I'm not using it, but
do you know, like, do you think that you could create something that would apply like equivalence partitioning or boundary analysis?
let's see if my how is the connection and how many credits I have. Not this one. Yeah, this one. So you can. I have installed something like an extension, not trying to promote anything, but just saying, right? An extension of something. And I played with it already to test it before coming here. But you can say something like, let me choose something. Yeah, you can say, for example, like, right, I don't help me write equivalence partitioning tests for the account archive. So this is an extension, but you can use whatever. I like this because it's and so this one, it's a kind of, it reads some things. I already have some things there, so it might not work. And it will try to propose me some things. It mostly failed because I already have them, but it can happen. This is a failed thing. No. Let me see if I can find something that because I played. Yeah. No, attendee record. Yeah, I played in different ways with it. Sometimes it works, sometimes not, like you saw now. But what you can ask is...
Like, is there anything that could give you a report on how much coverage you currently have?
About this one, no.
Not writing tests for you?
No,
like...
I don't think so. We barely have, but I don't see too much, what people are calling branch coverage. So in normal, you run your test suite, and you will get a line coverage. Was this line executed?
Do you think, like, is it possible? Like, I know it doesn't, I'm pretty sure it doesn't exist. The branch coverage I've seen, but based on your understanding of, like, you clearly understand these techniques quite well. Do you think it is something that an AI agent could be applied to? Like, is it just that no one's done it yet, and that's why?
To calculate the total number, this is the question?
Yeah, to like, I mean, we have branch condition analysis. Like, how hard would it be to bake a decision table generation into, like,
I mean, because they're systematic, it should be possible. I'm not sure how to, so to calculate the number of tests and maybe even give it a decision table and try to write at least the title of them, it should be possible. And I try to play with, like I show you, but sometimes it works, sometimes not now, but I think it may be. To actually check that, I'm more concerned with the idea, when executing them, do they really go through where I want at the end of an execution? Like, did I cover 100% of the possibilities? Maybe in Ruby we can. I mean, I think we can scrape something with trace point somehow to check some things, but I don't know. But I hope in the future I can only say to this AI at least things like, I want you to write boundary and equivalence for this method. and write it properly. I can say now, and I don't know where it's, I played with multiple extensions before the workshop trying to see if I can use it now, not for me to write the actual code because it's a lot. Not a lot, but I was losing time from the explanations. And sometimes it's not reliable. Like you saw, so for example, there it just deleted all the file now live. Like you proposed to delete all the tests that existed. So I don't know. But I'm hopeful that as time passes, because these are systematic in at least the known parts, we should be there and it should help us to say, cover it with these ones. Yeah. That also, I mean, if you can make it represent a graph out of it, I mean, that state machine should be able to be represented like a graph and then write on it. What I think it will be nice is to give it also the requirements, so then generate state from the requirements that they execute. But let's see. I mean, I'm trying to be optimistic in general. I'm an optimistic person, so. But I think it's important to understand, even if I ask it, why I choose these ones, and not only like to know what to ask, even if I don't write the test. Yeah. Thank you. As if we are discussing, just to put here, if you want to give me feedback, please scan and just write something if you want. It will be very useful for me to know about this. And if there are other questions.
Sir, I can tell that I don't have questions, but it's a beautiful speech. It's maybe a top 3 on this conference for me personally.
Oh, thank you very much.
The only question I have is that
is there any theoretical materials that I can study deeper on this decision making and specifically of partition making? Because, well, yeah, while your speech is quite clear and with good examples, maybe sometimes it's needed to dig deeper. So if you have any recommendations on resources, that would be great.
Yes. First, if you want to look about something that will, in general, help you, there are more techniques than these ones. There is a lot of material dedicated to testers, and I know that sometimes we don't go there. There are many books, but I can recommend the book. That's an old book, but it's called the Art of Testing Craftsmanship. I don't have it here, but I will search for it, and if I did not give you, you can contact me at. Let's make it. Sorry. On these ones. And I will write, but it's something like the art of craftsmanship testing, something like this. I will. Let's fix it now. Sorry, not to contact. The art of crafts testing book. I think this one. I don't download this, buy it, but this is the book. Sorry, that was the first recommendation here. This one, okay, eBay. It's an old book, but a very good one in the sense that, this is the book. I think you can find it on Amazon or something, at least why I like this a lot, and it depends on your taste, it has some mathematical theory before it goes into the techniques. It talks about set theory and group theory and probabilities and approaches, and then it goes into techniques. Sorry. Something like this. And just read this, and everything that I told you here is, you will see more fine-grained techniques like we discussed when you ask about the boundary, more fine-grained alternatives, or how to say variants of these techniques that you can fit, which I could not I just choose the main one that I know. And it goes also into more things. If you don't want to read this entire book, I recommend to search for something that is called modified decision condition, which is a technique that is concerned, when you have a big truth table, it's concerned to make sure that you test the influence of each condition individually in the final outcome of the decision. And it goes more into Boolean logic. And come on. I plan to talk more about these things. So far, it's just something with emails. I'm planning to do more workshops about these kind of things for developers, online ones. This just talks about a similar thing that it's today. There is no thing to subscribe, just you can put your email if you want, and I will send you and I'll launch something more. But I discovered that more people are interested, to my surprise, about this, so I'm planning maybe to do more about it. Yeah. Thank you.